All right, here we go. Moving right along. Page 2 of the Unit 5 test review. I believe this starts on question 9. If not, I'm missing something. Right, the point slope. So I talked about point slope previously in the last video. Point slope, of course, is y minus y1 equals m times x minus x1. All right, x1 y1 is a point. So we have a point, we have a slope. That's why we call it point slope formula. Now, unfortunately, with this problem, they only give us 2 points. They do not give us a slope. Well, we can find the slope. All right, not a big deal. All right, so because again, the slope, write down all these formulas again, try to commit these to memory. Y2 minus y1. Yes, I'll give you the formulas on the test, all right, but it's it's a lot easier if you just remember them. I'm tired of writing them down. All right, so we have x1, y1, and we have x2, y2. So this is going to be, so we got 2 minus -1 on top. We have 2 minus 3 in the denominators. All right, so minus negatives plus. 2 plus 1 gives us a 3 on top. Let me fix that. 3 on top and a -1 on bottom. If you want to simplify that, you can call it -3. All right, now the next part, we have a point. Now, the formula has x1, y1, so I'm just going to, by default, go to that one. It does not matter which one of these 2 points you plug in, all right? It turns out they are the same equation, and to figure out they're the same equation, turn them into y equals mx plus b. So kind of what we did in question 8. If you do that here, you'll see that both of them, it ends up being the same exact thing. So, anyways, moving on. Y minus y1, so y minus -1 equals m. Well, we just found the slope. The slope is -3. So -3, and then we have x minus 3. All right, that's perfect. If you leave it just like that, full points, you answered the question. All right. Now, the only thing I would recommend, just like a personal preference thing, minusing a negative looks bad, so I'm going to call it a plus. All right, so y plus 1 equals -3, and then x minus 3. All right. Now, there are some schools of thought that say you need to do this. Y equals -3, x minus 3 minus 1. All right, subtract the 1 over. If you want to do that, this is called the modified point slope formula. Is it any better or worse than that one? No, not really. 6 of one, a half dozen of the other, just personal preference again. All right. So you give me that orange equation, full points. You give me the purple equation, full points. You give me the red equation, full points. I don't care which one you do because those are all point slope. All right. We have answered the question in its entirety. All right. All right, enough of that. On to the next one. 10 through 13. Use the following diagram that is not drawn to scale. All right. So acute angles might not be acute. Obtuse angles might not be acute. All right. Obtuse. In the diagram below, angle ACE. Right. So ACE, this angle right here. Right. So there is ACE. I'm just going to draw it in there. ACE. That angle is congruent to BCE. So BCE is this guy right here. Right. So they're saying those are congruent. Whether or not they are congruent, it doesn't matter. Or whether or not you think they're congruent, doesn't matter. Directions say they are. So guess what? They are AF. All right. This segment right here is congruent to BF. This congruent. All right. So those, they don't look congruent, but guess what? They are. All right. What does it mean about point F? Point F is a midpoint. All right. It's a midpoint because it makes 2 congruent segments. And I want to point that out because a median goes from a vertex to midpoint. Right? Well, the vertex is C, the midpoint is F. So if we name a median, that is segment CF. All right, name an altitude. An altitude goes from a vertex to a, that looks bad, sorry, to a 90-degree angle. All right, so I see two 90-degree angles on here. GF is that, looks like a perpendicular, but it doesn't hit a vertex. All right, so GF is out. All right, so the only correct answer for this one is CD. Segment CD. It starts at a vertex, namely C, and it drops straight down to point D and makes a 90-degree angle. All right, how about an angle bisector? Well, they tell us right up top here, ACE is congruent to BCE. Notice how those both have the letter CE in them? Well, that's because CE is our angle bisector. All right, let me fix that. CE, segment, CE. All right, and the next one, name a perpendicular bisector. So this, we need a perpendicular and midpoint. Well, we have a midpoint. We identified that earlier on. That's point F. We need a perpendicular segment. That is GF. So guess what? GF is our perpendicular bisector. All right, now, just looking at this triangle, those are the only correct answers, I believe. Those are the only correct answers for this triangle. Sometimes there might be like multiple correct answers. I think that's all we got here. All right, let's see here. I think I have 2 more slides. All right. Solve for missing variables. So we got some triangles here. Let's take a look. We got some overlapping triangles. So this is kind of something straight out of Unit 4. So if I look at this triangle, I have a 30-degree angle up here. I have a 90-degree angle down here. So that means that this angle right here has to be 60. All right, so M equals 60. All right, now let's look at this other one, P. So segment, how about triangle? This triangle here. Notice how this triangle, I have a 90-degree angle right here, and I have an isosceles triangle. So we have point P right here. We have point N, angles. We have angle N right there. Well, guess what? We have an isosceles triangle. We have 2 congruent sides. That means we have 2 congruent angles. So what does that mean about P and N? Angle P, or P, just equals 45. And N also equals 45, right? 45 plus 45 plus 90 gives us 180. So that's how I figured that out. We had to use the idea that, hey, that is in fact an isosceles triangle. Therefore, those must be congruent. All right, so that's kind of what's going on there. I think I got them all. All right, on to the next one. Solve for x. Now, this segment right here, this is what we call a mid-segment. What was a mid-segment? So if we look at this red dot I just drew, that is a midpoint. We know it's a midpoint because these 2 segments are congruent, notated by those 2 tick marks. Well, there's also another midpoint up top, right? Because we have those 2 tick marks there. So that orange line is what we call a mid-segment. It's the segment that connects 2 midpoints. And there was a theorem. I don't know if it was a theorem or a definition. I think it was a theorem. I think we proved this one, maybe. The mid-segment was half the length of the base. All right, so if I throw some letters on here, all right, maybe I call this M, N. All right, we usually use M and N for midpoints. I'm going to call this A and B. All right, so if I wanted to think about this, formula-wise, I could say, all right, 2 times Mn, or 2 times the length of Mn equals AB. All right, so in other words, if I take the mid-segment and I double it, right, that gives me the base. All right, so let's just put that all in there. So 2 times 4x minus 2. All right, so there's that mid-segment. If I double it, that equals 14x minus 22. Okay? And we solve, right? So you got 8x minus 4 equals 14x minus 22. And we keep going. What would you do next? I would probably subtract the 8. 14 minus 8 gives me 6. All right, if I work this all out, negative 4, still got the minus 22 there. Maybe add the 22 to both sides. 6x is going to equal positive 18. Therefore, x equals 18 divided by 6 gives us 3. All right, and that one's done. All right, I think that's all they wanted. Solve for x. If they said, hey, plug it back in, we could. You know what? Why don't we do that? X is 3. So 3 times 4 is 12. 12 minus 2 gives us a 10. So this has a length of 10. All right, 3 times 14 is going to be 30, 42. 42 minus 22 gives us 20. We'll look at that. MN was 10, AB is 20. We said it needed to be half, and it is. All right, beautiful. Last page, here we go. I got some centroids, and I know that these are centroids because B is a midpoint, F is a midpoint, and D is a midpoint. I know those are midpoints because we have all those tick marks telling us side lengths are congruent. That means we have 3 medians. CF is a median, EB is a median, and AD is a median. So when we had a centroid, we had to kind of think about it. So before I do this problem, let's just kind of review here. This piece right here, it's kind of a longer piece. All right, if we look at GF here, it's kind of a shorter piece. All right, that orange piece right here, this was 2/3 the overall length. All right, so CF is 2/3 the overall length of the entire segment. All right, GF is 1/3 the overall length. All right, so for example, if this whole thing, I'm just making up numbers. All right, so if this whole thing, so if you're watching this on mute, you're gonna be really confused. If this whole thing has a length of 9, all right, then that means this piece right here has a length of 6. And this piece right here has a length of 3. All right, so we're just breaking them up into 1/3 and 2/3. And notice how these two, right, it's always half of the bigger one, right? So the small piece is always half of the big piece. And the smallest one is half, 1/3 of the whole thing. So let's try to put that into words here. So GE, so they're telling me GE, this guy right here, all right, is 5x minus 2. And then they're saying GB. So this guy right here is x plus 5. So from earlier, I said the green piece is always twice the size of the blue piece. So here's what I'm going to do. I'm going to take the blue piece, and I'm going to double it. I'm going to say 2 times BG, right, is going to be equal to the green piece. Right? And that's my equation here. So we can plug everything in. So I have 2 times x plus 5. Right? This is going to be equal to GE, which is 5x minus 2. All right. So let's solve this. I got 2x plus 10. 5x minus 2. Move some stuff around. 3x equals 12. All right, add a 2 on both sides, subtract 2x on both sides. Divide away a 3 now. We're going to get x equals 4. I think that's all we had to do. Find x. All right, solve for x. That's what we did. So x equals 4. That guy. Right. And again, if we wanted to plug it in, since x is 4, this gave us a 9. This gave us 18. All right, so that makes this whole thing here is 27. All right, so 27 times 1/3 equals 9. All right, so that's how we could check ourselves if we wanted to. We know 2/3 of 27 equals 18. Right, so that works. We know 9 is half of 18, so that also works. All right, so there we go. That's how we could check ourselves. All right, last one, faces in the way. Let's do this. So I got GD Here's GD. All right, and then I have AG. All right, so same kind of thing. I see a squared. You know what that means? We're probably gonna have to factor. So let's look at this. GD is a smaller one, so I'm gonna double it. 2 times GD. All right. That is going to be equal to AG. All right, so let's see what happens. 2 GD, so 2 times X plus 4, that is going to be equal to X squared minus 32. All right. Switch one color. I'm going to distribute. I got 2x plus 8 equals x squared minus 32. Now, I have an x term, I have a number, I have an x squared term. This is a factoring problem, so we need to factor. All right. When you factor, we haven't done one of these in a while. Move everything to one side. So subtract the 2x. Subtract the 8. All right. Then put everything into standard form. So we're going to say 0 equals biggest exponent first, x squared minus 2x minus 30. Minus 30. No. How about minus 40? There we go. Much better. That could have been bad. All right. Here we go. Right at standard form, biggest exponent, the smallest exponent. Everything's on one side is equal to 0. Now we can continue here. So 0 equals, let's go ahead and factor this. What times what gives us x squared? How about an x and an x? What times what gives us a 40? Well, unfortunately, there's a ton of stuff. So I got 1 and 40. I got 2 and 20. 3 doesn't work, but 4 does. I got 4 and 10. 5 and 8. I don't think a 6 works. No, it doesn't. Neither does a 7. Neither does an 8. I'm starting to think I made a mistake. Did I make a mistake? It does happen every now and again. AG is x squared minus 32. Negative 32 minus 8 more. That's a 2x. I don't think this one works. I don't think this one factors. Yikes. Okay. Right. GD is the small one, so I need to double it. So 2 times x plus 4 is 2x plus 8. Great. I have AG, that's x squared minus 32. I just write that one straight down. Minus 2x minus the 8, 32 minus 8 more gives us 40. Maybe if I have I think there's a typo here. Here's what I'm going to do. I'm going to change the problem so I'm correct. All right, this x squared, this plus 4. I'm going to change this. Let's get rid of this x plus 4. I'm going to call this an x minus 4. All right. This way, I'm not wrong. All right, if I'm ever wrong, we just have to change the math so I'm right. So we have a minus 4. So that's going to change everything. So here, I'm just going to start over. All right, that means this is wrong. All right, so take 2. Here we go. I'm not remaking a new video because this is the last problem. This gives us a 2x minus 8. This equals an x squared minus 32. Right? And we're gonna reprint these before you guys even see this, so hopefully it's all right. Let's see here. Still a factor problem, so we still need factors. So here, let me write that over here. All right. Add the 8, subtract the 2. I'm gonna write all that down. Minus 2x plus 8 minus 2x plus an 8. We have 0 equals x squared minus 2x. Let's try this. How about minus 24? I said 24 and I wrote a 26. Let's try 24. All right, so we had 0 equals, I bet this one factors, and I know this one factors, an x and an x. What times what is 24? How about a 6 times a 4? Are they 2 apart? Yeah, they are. So let's make it a -6 and a +4. Therefore, x equals 6, x equals -4. Now, one of those is extraneous. Which one's extraneous? I'll let you kind of figure out why, but the answer is -4. So think about why -4 doesn't work in this case. All right, but there we have it. That was the end of the second video. Let me go fix this in your review packet so you don't make that same mistake I did. So we'll see you guys in the third video here.